This presentation will focus on the importance of appropriate reporting of critical minerals estimates to assist governments and investors in achieving their objectives with respect to critical minerals. I will use the term critical minerals in this presentation, but it's taken to include the term critical raw materials, which is used in some cases. I consider the term strategic minerals, which is also used occasionally, to be a subset of critical minerals. Critical minerals have two common characteristics. Firstly, they're essential for the functioning of modern technologies, economies, or national security. And secondly, there's a risk that their supply chains could be disrupted. As such, what's considered critical in one jurisdiction may not be in another. Those working in the industries that rely on them, and government planners and investors, need to have reliable estimates, particularly of the location and magnitude of available resources and reserves, as well as projections of the future supply capacity. These tables show the JORC estimates of ore reserves and mineral resources for the Mount Weld rare earth deposit in Australia. The grades are specified in terms of total rare earth oxide content, which is explained in the box outlined in red. The text highlighted in blue states that the mineral resources are reported as inclusive of ore reserves. So from an inventory perspective, it's important to realize that these two estimates overlap and cover the same volume of ground, such that it would be inappropriate to add them together and use of the total for forecasting available supply. Interestingly, the announcement which accompanies these estimates states that the ore reserve update will support at least 35 years mine life at a production capacity of 7,200 tons per annum of neodymium praseodymium oxide finished product. From Table 7 in the accompanying announcement, one finds that in fact neodymium and praseodymium represent only 23.4% of the total rare earth oxide content. Personally, to adhere with the principle of transparency, I think that if neodymium praseodymium oxide is the main revenue product for the operation, then their proportions by grade of the total rare earth oxide content should be indicated in a footnote to the table. This table is based on an Australian government report on the country's rare earth resources and reserves. In footnote 3, you'll see that the data is based on mineral resources reported inclusive of ore reserves, and that not all mines report mineral resources. This is likely to be the cause of the discrepancy in the mine life, where the resource life 1 is less than the reserve life. Since ore reserves are based on measured plus indicated resources, one would expect the resource life to be greater than or equal to the reserve life. This difference is likely due to the fact that mineral resources data was not available for all of the deposits considered. You'll also note that the estimates shown here are based on total rare earth oxides, so this does not address the issue of the availability of specific individual rare earth elements which may be regarded as critical or strategic. In many cases, these are not reported as part of the ore reserve or mineral resource statements for reasons related to sampling and analytical accuracy and the expected mineral products to be produced. You can also note that in calculating the resource life, the assumption is that there will essentially be 100% conversion of the mineral resources to production, which may not always be a valid assumption. In the European context, there's been a lot of interest in critical minerals in recent years due to the European Commission's concerns over the energy transition and the resilience of raw materials supply chains. This led to the introduction of the European Union's Critical Raw Materials Act in May 2024, and its requirements are currently in the process of being implemented. The map shown on the right was prepared as part of the CRMA project, which investigated how best to combine minerals data obtained from different sources across Europe. It illustrates the variety of different national mineral resource reporting systems used, which obviously pose the challenge in terms of combining minerals data from these different sources. The CRMA project concluded that the United Nations framework classification would be the best option to use as the basis for combining data from such disparate sources into Europe-wide databases for use in strategic planning on a transnational basis. It's likely that the conclusions of this project were taken into account when developing the European Union's Critical Raw Materials Act, which includes specific reference to the use of UNFC when reporting on critical raw materials projects, as indicated here. For those working in the mining industry, the most important reference to the UNFC is in the context of strategic project applications. Here, I should note that this is relevant not only for projects in Europe, but can also apply to projects in other jurisdictions, particularly in countries which have signed a partnership arrangement on raw materials with the European Union. This includes Australia, Canada, Chile, and Kazakhstan, amongst several other countries. The first round of strategic project applications closed in August, and these are currently being assessed. The European Commission has reported that 170 applications were received, of which 77 were focused on extraction, 58 on processing, 30 on recycling, and 5 on substitution. The variety of different project types highlights one of the reasons the UNFC has been used in the Act, since it allows classifications to be derived from a variety of different project types, many of which, such as recycling and substitution projects, are not covered under Crisco type reporting. Moving on to the question addressed in the title of the presentation, the diagram here summarizes some of the differences and similarities between the two different types of reporting and classification systems. The Crisco ellipse on the left represents reporting to investors, and the UNFC ellipse on the right represents reporting to governments. The Crisco-aligned codes and standards would belong to the left-hand group, and other systems such as the Soviet GKZ system might also be considered to belong on the right. The two groups have in common the estimation of quantities, consideration of the degree of confidence as communicated by the classification of estimated quantities into different classes. Both systems also consider both geological knowledge and the economic and feasibility aspects of projects. However, the Crisco systems focus on information to be used by investors and are limited to use in the minerals sector. As you'll be aware, they're also based on the principles of competency, materiality, and transparency. On the UNFC side, the focus on reporting to governments, and you'll note that the UNFC can be applied in a wide variety of different sectors. Until recently, the UNFC specification itself did not include any guidance on competency. However, in 2022, a supplementary guidance document on competency requirements was issued, which explains the term qualified expert. The diagram highlights the fact that the two systems are complementary systems with some common characteristics, but best used in conjunction with one another because they were designed and serve different purposes. To conclude, this diagram is the earliest version of what is referred to as the McKinsey box, which was published in 1972 and was subsequently adopted by the United States Geological Survey and the United States Bureau of Mines, the USGS-BM. It's one of the earliest diagrams which shows the use of the terms resources and reserves in a complementary manner on the same diagram. However, their usage on this diagram differs from the current Crisco usage as illustrated by the overlay. This shows how Crisco definitions of mineral resource, mineral reserve would correspond with the reserves box indicated in the McKelvey diagram. On the right are some of the issues which may be considered important in current discussions about minerals. Four are self-explanatory. Contingency refers to cases where some minerals or materials may become more important in the future due to the development of new technology for extracting and or using them. This would cover issues related to security of supply, ports, and permitting. Finally, some challenges that need to be addressed. If we accept that there's a need for separate approaches to public and non-public reporting, then we need a framework for managing data and estimates in this context. For instance, resource estimators will be familiar with the situation of having a block model estimate where a cutoff is applied and blocks are classed as mineral resources. But what happens to the blocks which fail to satisfy the reasonable prospects for economic criteria at this stage, or indeed prior to reporting a mineral resource in the first instance, what's termed beyond inferred or before inferred in some discussions. What do we call aggregate estimates of such material that cannot be publicly reported under CRISCO rules? With regards to the reference point of estimation, as is included in the CRISCO definition of mineral reserves, this needs to be given more consideration. Critical raw material policymakers are concerned about the supply to industries, so maybe the metals sector should be focusing more on estimates of saleable products to supply industrial mineral processes, as is already common in the industrial minerals sector. For instance, rather than talk of zinc mines, perhaps we should talk of sphalerite mines which produce an intermediate product. Some strategic minerals such as germanium and indium are only recovered during later processing stages and are rarely quoted as part of mineral resource or mineral reserve statement. I recently heard the term carrier mineral used in this context. A final issue is the need to communicate information about the timelines in which materials will be available. I think that many government policymakers have an unrealistic view of the time taken to develop mining operations and bring material to market. Before taking questions, I'd just like to note that the QR code shown on the slide provides a link to a longer presentation, which I gave earlier this year on the same general theme. It provides more detail about some aspects such as the Critical Raw Materials Act and the CRISCO template to UNFC bridging document.